Assessing the quality of exam questions, multiple choice questions, whether they are good or bad, using item discrimination analysis in Excel by calculating statistically point-biserial correlation coefficient. Item discrimination. Item means a question or refers to a question. Item discrimination assess the exam quality, assessing each question in exam sheet as either good or bad question. It does differentiate between students who have mastered the subject content from those who have not. It does determine how well an item is discriminating between good and poor students. Point-Biserial correlation coefficient assists the educator or educators to identify good or bad test questions. So the coefficient is one of the item discrimination index. It does measure the discriminating power of an item or a question. It is a method of measuring the relationship between student total exam scores, continuous variable from 0 to 100, and students' item mark or score, dichotomous variable. Dichotomous mean two categories, correct or wrong answer. It does measure the strength of the relationship between two sets of data. So here in this case we have two variables. We need to correlate two variables with each other. One of the variable is continuous, such as the total mark, which is in percentage from 0 to 100, and the other variable is categorical. Two categories, correct or wrong answer. The test, statistical test, the point-biserial correlation coefficient, does measure the direction of the relationship, and it does calculate the significance of the relationship by producing a p-value. A p-value less than 0.05 indicates significant relationship. P-value greater than 0.05 indicates non-significant association. Now, the statistical test for point-biserial correlation coefficient generates a value or values, and these values range from -1 to +1. +1 indicate a perfect correlation, positive correlation. A -1 indicate a negative correlation, a strong one. Now, positive value of the coefficient indicates that the learner who answered a given question correctly also have a high score on the overall exam, and those who answered the same questions wrongly have low total mark in the test. A high positive value indicates that the question is discriminating high performing students from low performing students. Negative coefficient value means a high performing students are getting the answer wrong and low performing students are getting it right. In this case, remove the question from the exam paper. However, if the coefficient value is 0, that means the item or the question is not discriminating between students. So it's worth changing it or modifying it. In this small table, any value of point-biserial that is greater than 0.4 indicate that the question is very good, and a value of 0.25 to 0.4 suggests a good items. Fair item have a point-biserial value of 0.15 to 0.25. Any question that have a value of point-biserial of less than 0.15, then it is a bad question or a bad item that worth modifying or omitting from the exam. Here in this table shown an exam result for 15 students answering 15 questions and multiple choice questions, and each question is recorded the score for it as either 0 on 1, 1 is correct answer, 0 wrong answer. To perform biserial correlation coefficient statistical test to perform the statistical test to generate the coefficient or calculate the coefficient, we first have to calculate the correct answer that each individual student has achieved, and then by adding all the questions scores for each individual student together, divide them by the total number of questions, in this case 15, and then multiply them by 100 to generate the total mark or total score or the percentage of the total mark as it is given here in the blue marked values in the column labeled as mark. So for in the point-biserial correlation, once the total mark is calculated, the test is performed and the test will correlate each specific questions, the value in each questions, the scores in each questions with the total mark as shown here in this again slide. To calculate the R, which is the coefficient, or to execute the point-biserial correlation statistical test to generate the coefficient, take every question with its value and scores 0, 1 and correlate that with the total mark for the whole students. And we do this for every question or every item to generate specific R value for each question and a P value for that question. This is how it is done in a statistical package or software. In this slide, this is a scatter plot showing a correlation between wrong and correct item, an answer wrong and correct for question number 5, and as we can see here in the y-axis is labeled as exam mark from 0 to 100, and on the x-axis it is labeled from 0, 1. 0 means wrong answer, 1 means correct answer. As we can see here, most of the students that who answered question number 5, item number 5, tend to have higher overall exam mark compared to those who had answered the question number 5 wrongly, tend to have lower total score or total mark. So this question 5 from this scatter plot can be considered as really a good questions. It can discriminate between the high performing student and low performing students. The next slide shows item analysis using the point-biserial correlation coefficient either in SPSS or in another package software called Excel. As we can see here, for each individual question, there is a value calculated for point-biserial value calculated and a p-value for question number 1 to question number 15. Again, here we have questions with their point-biserial value and p-value. In the red labeled scores question number 1, we see that the value is negative and it is not significant because the p-value is greater than 0.05. Again, this question number 1 indicate that higher performing students are answering this question wrongly and low performing students are answering it correctly. So this question is a very bad question that need to be removed from the exam as it is negative. If we look at the question number 6, which is labeled yellow, we can see the value for the coefficient or the R is close to 0 and the p-value is very high. So this question is not discriminating between high and low student. So it is close to 0 and it's considered to be a bad question and it's either required to be modified or omitted from the exam. If we look at question number 11, 12 and 13, we can see that the R value is very high, 0.51 for question number 11, and the p-value is less than 0.05. So this question number 11 is a very good question in discriminating between students. So it is classed as or categorized as a very good question. Again, number Q12 also a good question as it is the value for it 0.33 and the p-value less than 0.041. And the same thing for question number 13. It is, we can call it a very good question as the value, R value is 0.48 and the p-value is very low. If we again go back again and look at question 2, we can see that question 2, the R value is 0.15, which is, we can call it a fair question. However, since the p-value is not significant, then this question also is not discriminating between high and low performing students and need to be remodified. Again, from this table on the bottom, we can say that question number 3 is a good question. Question number 4 is a very good question. Number 5 is a very good, if not excellent question. Number 7 is not a good question. Number 8 is a good question. Number 10 is a good question, and 11, 12, 13 I have described them. Number 14 is a very good question. Number 15 is a very good question, and number 16 I have the data for it, but it wasn't included in the tables. But again, number 16 here, it is a very good question as the p-value is less than 0.05. So this is the way to use the power of the point-biserial correlation coefficient to determine the R value and the P value, and to look at the correlation between specific question and correlating it to the overall mark to determine whether the question is good or bad. Assessing the quality of multiple choice questions in an exam sheet by evaluating the ability of the MCQ or a question, its ability to discriminate between a high performing student and low performing student, i.e. measuring the power of each individual questions in its ability to differentiate between good students and high quality students and low performing students, based on evaluating each specific questions, whether it is a good questions or a very poor questions that probably require replacing or removing. The way to do that is to use an item discrimination analysis in Excel based on point-biserial correlation coefficient. Again, this assessment of the questions is of a great benefit for those who are involved in education and designing exam sheets or paper, and to want to make sure that the questions serve the objective of their subject or taught modules in a way that it will fulfill the requirement for, and it assess the learning objective of a module. So doing an item discrimination analysis is an important step in assessing exam questions, multiple choice questions. I have generated, as I said before, a video clip describing what is point-biserial correlation coefficient and the background for it. For those who are interested, feel free to look at the video in my YouTube channel. Here in Excel, I have entered a data from an exam result for 38 students answering 76 multiple choice questions from question number 1, Q1 to Q76, and each individual or each student answered the questions, the data recorded or entered as either 0 or 1. 0 stands for wrong answer and 1 indicates correct answer. So each questions has a value or a score of either a 0 or a 1 answered by each individual student. 1 for correct answer, 0 for wrong answer. So here in these questions we have only 2 types of scores, 0 or 1, which would indicate that it is a categorical data, so just 0, 1, 0, 1. And if we want to evaluate each questions and look at the quality of each multiple choice questions of those 76 questions, and the first step to do that is first of all to calculate the overall exam score for each individual student, or the total score that each individual participant had achieved in the exam. And the way to do that is to scroll here to the far right, and I'm going to generate a new column, and I'm going to call it total score. And the way to calculate the total score is to add up all the value or the scores for each individual participant has achieved for all the questions, 76 questions. Add them up, the value for them, then divide them by 76 and then multiply them by 100 to calculate the percentage of the correct answer or the total score, which we are going to use these scores in subsequent analysis. And the way to calculate that is if we just click on the cell here and then click on the symbol here indicate. We can use two methods here, either using the sum, adding up all the value, or use the average. And I'm going to use the sum method, in which I'm going to select the question number 1 to question number 76 as it's showing here, equal sign sum P2 to PY2, and I'm going to divide that by 76, since we have 76 questions, and then multiply that by 100. So the total score, or the percentage of the mark for each individual student for the exam, first one is 82. And if I select and drag the cell toward the end, it will autofill the total score for each individual participant or student. So here we have 76 questions scored as either 0 or 1, and a total score of 38 students, and the scores in a percentage. So here we have a categorical data for each one of these questions, 0 or 1, and a continuous data percentage from 0 to 100. And to determine which one of these questions is discriminative between students or not, you need to do a point-biserial correlation coefficient. And point-biserial correlation coefficient is based on Pearson correlation coefficient. And to do the analysis, we need two sets of data. The first set is dichotomous or categorical, as we have here the questions, and the second one is the continuous. So we need continuous, which is the total score. So we need to correlate and find the relationship between each individual question with the total score. So we need to study the relationship, calculate the relationship through a statistical test of point-biserial between each individual question and total score, and to generate a value for the correlation, and this value indicates the strength of the relationship. And the way to do that in Excel is if we click on data and then click on the data analysis. Either way, if you don't see the data analysis icon on your Excel sheet, the way to bring it on is click on more and then go for options and then scroll down to add in, and then scroll down here to manage add in, and click on this analysis toolbar, which will make the icon appear here. So if we click on the data analysis, and then I'm going to, here we have a list of tools or tests to use. And we're going to select correlation, since we are looking at correlation, and this will use the Pearson correlation coefficient. If we click on OK, another window appears, and we are going to input the range. So we are going to correlate the data, the total score, with all the 76 questions. Then we need to click on this arrow, and I'm going to click here then scroll to the beginning of the up to Q1 and then hold the shift key and click on Q1. Again, the data that we need to include is highlighted, and then click again on shift control and on the below arrow. This will select all your data that you want to correlate the total score with all the questions. And if we need to keep this label in the first row ticked in, and we're going to generate the correlation in a new worksheet. If we click on OK, again a correlation matrix is generated, as we can see here, in which each question, so you look at the bottom one here, each question is correlated with the total score. Total score correlated with the question 1 up to question 76. So now here I'm going to rearrange and delete the data that I don't want. So I'm going to get rid from this row up to 76. So by holding the shift key, click, and then right click on it, I'm going to select delete. Again, this will delete the other data that we are not interested in. So here what we have is the correlation between question number 1 and total score or overall mark, and question 2, 3, 4, and so on. And to rearrange the data in a much better way, we highlight this row, then right click on format the cell, and I'm going to click on number, and I'm going to use only 3 decimals to make the value here easy to compare. So here from this data we can see that we have the correlation coefficient for all the 76 questions, and each question has a value. I'm going to get rid of the last one because it's correlating total score with total score will be 1. So to delete this one. So now we have the value, the coefficient value, the Point-Biserial coefficient value for all 76 questions. And in fact, I want just to color code those value so that will be much easier to look at the data. So if I highlight the row for total score and then click on home and then click on conditional formatting, then click on new row, and in the new row I'm going to use a 3 color scale, and I'm going to change the type into number for all the minimum, the midpoint, and the maximum. And I'm going to enter here as a -1, since the range for the Point-Biserial coefficient is from -1 to 1. So, and I'm going to keep the midpoint 0. The maximum 1 is here is 1, and I'm going to change the color. For the minus, we need to make it red. For 0, which is, I don't want to make it white, as it is this indicate no correlation. And for the maximum 1, put the color coded with a green. If I click on OK, in here again color coded, all these cells are color coded again according to the value within it. As we can see here, that the higher the value, the more greenish the cell will be, as here the correlation coefficient is 0.76, and here is a poor correlation of 0.15, and here also a 0.05, and also interesting really toward a pinkish, toward reddish color, which is indicate a minus correlation, and here also a minus correlation. Now what does this value mean? This value means that if you have a value of P, I'm going to call this point Point-Biserial, as this is the Point-Biserial now, and then I'm going to make it a little bit darker. So what does this value mean? Indicate that the closer the value to 1, the stronger the correlationship between each questions and the total mark. So in this case, anything above 0.15 is a fairly good question, or anything from over 2.25, it's a good question, and anything over 0.4, it is a very good question. Any value close to 0, as here, it's indicate that there is no correlation between the question and the overall score, i.e. this question is not discriminative. It doesn't discriminate between high performing and low performing students. So this question needs addressing either by remodifying it, rewriting it, or excluding it and removing it from the exam sheet. A negative value here indicates a problem, as it is minus 0.294. This indicates that high performing students answered this question wrongly and low performing students answered the questions correctly, which doesn't make sense. So there is something wrong with these questions, and the best way for it is to exclude that question and remove it from the exam. And also similar things to this, also question number 70, as it's also negative. So negative mean it is a bad question. So it's to get rid of this, anything close to 0 or minus need to be removed, and as it doesn't discriminate between individual. So this is the way to discriminate between questions and find out which questions are good and which questions are bad, which questions to keep and to use in the future exam sheet, and which one to replace or rearrange or rewrite. Now, this value here for the Point-Biserial, although it is, some of these values are high, but again, this value has to be statistically significant, has to be confirmed by calculating the p-value. So p-value for each correlation between questions and overall score is need to calculate the p-value, as the p-value is the determinant factor in the significance of the relationship between the questions and the overall score. So to calculate the p-value for each individual questions, correlation of each individual question to total score, is to click on, if we go here again to this data, and we want to calculate the p-value, I'm going to select some. Unfortunately in Excel we only can do it one by one questions by one, so we need to calculate the p-value for question 1, and then question 2, and then up to 70, question number 76. So I'm going to select question number 5 here and calculate the p-value for question number 5, as the p-value here for question number 5 is 0.76, which is very high, but is it significant? And the way to find out the significance is to calculate the p-value. To calculate the p-value for number 5 here, need to click on the data, then icon for data analysis, then scroll down here on the list and use the regression. We are going to use the regression to calculate the correlation between these two variables to get a p-value. So if you click at OK, and in this window we are going to enter a data for y-axis input. In case it is a correlation, it is a regression, then you have y-axis and x-axis, and it's a correlation between them, and then calculating the p-value. For y-axis we are going to use the score data here, as it is selected total score, as this is the overall mark. And for the input, again we're going to select that, we haven't selected that. If I click on this here and then hold the shift control and down arrow, it will select just only the data and the label for that column. and we'll do the same thing for input. For the input X range, I'm going to use calculate the p-value for question number 5. So I want to scroll to number 5, click on it, and then hold the Control Shift and then arrow indicating to the lower arrow, and then click on here again. As you can see that number 5, let's do it again, double check. So if we go for number 5 here, click Shift and then black arrow is selected here, as we have seen here, 5 and arrow column 5 is selected, and then click on label, and we are going to generate the output in a new worksheet. If we click on OK, here a few tables are generated. What is important here in this tables is we need to look at just only the question number 5 here. I'm going to highlight that with the yellow color, and of all this, what is interesting to us is the p-value. This p-value, as it is. Again, this video look like a little bit complicated, so we need to change the format of the cell to a much easier decimal point. Change it to 3 decimal point. Again, as we can see, this is the p-value correlating question number 5 with the overall mark, and the p-value for it is 0.00. So question number 5 here, if you go back again to the MCQs, question number 5, and here in this sheet, question number 5 has a p-value which is equal 0.000. So again, we need to set up this for the format of the cell into 3 decimals, so we need to see the decimal. Click on OK. I see the decimal. So this question number 5 is really an excellent question. First of all, it has a high value for the correlation coefficient 0.76 away from 0 toward 1, and a statistically significant p-value which is 0.000. And for the p-value, for anything to be statistically significant, the p-value has to be less than 0.05. This is the cutting point. Anything less than that, then the value we are looking at is significant. So it is significant or important value. Anything below 0.05, this is significant. Then this value of 0.76 is a significant value, which means that this question number 5, is a very good questions, a very excellent questions to keep for discriminating between students. I will also look for another example here, and I'm going to look at question number 6. As we can see here, the correlation value is 0.05, which is close to 0, which might indicate that this question is a bad question. Again, we need to calculate the p-value for it, as without p-value we cannot really make a conclusion on the quality of these questions, as the value for Point-Biserial by itself is not enough to judge without the p-value. So we need to find out the p-value, and to find out the p-value, again we go to the MCQ, the sheet, original sheet, or data. It has data in it, and then data analysis, and then regression again, and we are going to use keep y axis or input y range as the total score, and the x range we're going to select number 6. If I select, then Control Shift and below arrow, and then click on here, click on label, keep it as it is, and click on OK. Again, another regression tables is generated. We have to do again the same changes. Change this into, format the cells, change it into 3 decimal points. The p-value is 0.79. If we copy this and we go here to this 0.7 and place it here, 0.749. Again, if we look at the p-value for here, it's very high. It is above 0.05. So once we see this value here, so we have to reject this value, this reading or this value from correlation coefficient, and we say that this questions is poor questions, and we should not consider this questions in the exam, as the correlation is very low and at the same time it is non-significant. Now, one last point before finishing, I want to pick up a negative question. I'm going to do the same thing for negative question. Here for question number 47, we have a correlation coefficient minus, which indicate that the question is not discriminating, as in this question, high-performing student answer this question wrong, and low-performing students answer it correctly. So we need to find out whether this question is worth considering. Again, if it is minus, then it does not worth considering and it's worth removing it. It is important to remove this question as it is not discriminative. But again, we had to determine the p-value for this correlation value, which is minus 0.294, and the way to do that again is to go to the MCQs and then data, click on data analysis, regression again, changing that into selecting now the data number or question number 47, click, Control Shift, below arrow, and then click on OK. Again, another table is generated here, and as we can see here, the value, again changing these things into formatting the cells, so making it 3 decimal points, copy MCQs, and going to our first sheet here, and we're going to place the value here. Again, this is the p-value for this test when we correlate question number 47 with overall scores. It gave us a minus 0.29 value and a p-value of 0.07. Again, this value is greater than 0.05. So in this case, we discard these questions as the correlation is not significant, and it is essential to remove this question from the exam. And again, you have to do these steps one by one for all the rest of the questions. You need both the value for the coefficient and the p-value to make your judgment on the question. So this is the way to do the analysis item called item discrimination or question discrimination analysis, to discriminate analysis that will discriminate between high performing and low performing based on the questions, evaluating the questions using a point-biserial correlation coefficient value with a p-value for it, statistical significant value for it. So this is the way to judge whether a multiple choice question is a good or bad question, and this can be of a tremendous benefit to those who are involved in education and assessment and designing exams that is of a high quality and high standard one.